It's wrong.
It's right. Two wrongs don't make a right, but three lefts do. Anyway, whenever, thank you. Whenever you stand up. Stand up.
Just like 3 rights make a left.
Yeah, but if you're at an intersection.
All right, turn left. 90 degrees.
But
Turn left 90 degrees. Turn left 90 degrees. Turn left 90 degrees. Now aren't you turned right?
But now the same straight.
You might be. Whatever. So when I'm setting up these problems that go through with leading term coefficient not equal to 1, I know that there are many different ways you guys have all seen how to do these. The way that I set these things up forces you into grouping. I've always found that a grouping setup is always, while it may take a minute or two longer to solve a problem, I found that it forces you to really think about what you're doing. So here's how it looks. Remember, I take 3 times 10. I'm looking for the factors of 30 to add to 17. What times what's 30, but you add together to get 17. Now, you get 15 and 2. One thing that people were freaking out about sometimes is that you forgot your factors. Well, if you go to your y equals button on your calculator, and what I want you to do is type in 30 divided by x. There we go.
Equals?
Whoa.
No, I don't even want to bother looking at it. I want to do my table right away. Let me show you what you're looking at. What you're doing here is you're figuring out what are factors of 30.
Oh, that's so magic.
It is. If you go to, what was it, 30? 30 divided by x, and I go right to my table. What it's doing here, it's listing out all the different factors of 30. Oh, my table set is still on. Now, if I look at my table set, why is it all messed up?
It's alright.
Oh, it's starting there. There. As I'm scrolling through, 1 times 30, 2 times 15, 3 times 10, 4 times 7.5, 5 times 6, 6 times 5. These are all of my factors of 30. So if you forget what your factors are, or it's a large number and you're not sure exactly what it is, it's a real nice, easy tool that you already have in your fingers that you're able to set up. So in this case, we had to get multiples of 30 to add to 17. Is that right? Was it 17?
Yes.
All right. So it was 15 and 2, right?
I thought it was 10. Or like.
Yeah, 3 times 10.
Oh.
That's where we got it. I think it's the other one. So here I know that's going to be 15 and 2. So what we're doing here is we're splitting apart that middle term. I'm taking the 3 terms and writing it out as 4. So I get 3x squared plus 15x plus 2x plus 10. Now, does it matter which one I put first, the 15 or the 2? It makes no difference. One suggestion I will make, though, if you have alternating signs, a positive and a negative, put the negative one first. You tend to make less mistakes if the negative is first. Now you just group them. What's my GCF of 13x squared and 15x?
3x.
3x. So I'm left with x plus 5. What's a GCF of 2 and 10? Are these the same? Write it down. Then you're left with 3x plus 2. And you're correct.
Why do we have to do all that?
Yes!
Can we just do like, I just did it in my head where I was like, oh, well, 3 times 5 is
It's fine.
15.
It's fine.
Alright.
If you can go through it, it's fine. I have no problem.
So x
What I'm doing here, there's no equal 0 here, so I'm not worried about it. But yes, if it was, my zeros of this would have been -5 and
-2.
great. So all I'm looking at is I know there are many different ways to set up and factor. If you can do it via the guess checker, you know what the terms are right away, go for it. I'm not going to stop you from doing it one way or another. When I do the problems on the board, I'm always going to kind of go this way. Yes, ma'am?
How could you like jump to the x is 5? How could you just like go right to that from the 3x from on the top? Like,
You really have to know your times tables and
okay,
stuff.
now I see.
what this is, you're like trying to go right from the trinomial to the factor
No,
term.
no, I mean like from the second to last step to the last step.
Oh, here?
What did you do?
Oh, do these guys have the same thing in common?
Yes.
Write it down. What's left? 3x plus 2.
Okay.
It's another GCF. Greatest common factor here. I can factor out the x plus 5, and what am I left with? 3x plus 2.
So what's the legal answer?
X plus 5, 3x plus 2. Those are your terms. You can put them in either order.
Alright.
What property in math tells you the order doesn't matter when you multiply? Very good. 40.
40 is something.
What times what is 60?
-4, -13.
That adds together to get negative 19. Like she just said, 6. Like she just said, since the multiple, when you multiply them out, is positive, but when you add them, it's negative, that means they both have to be negative. So you're looking for the factors of 60 to get you negative 19, and it was negative 4 and negative 15. So now when you go through to factor it out, 10x squared, bless you, minus 15x, minus 4x, plus 6, and now I have to do my grouping. One trick I will tell you, if your third term is negative, do a same change opposite, because it'll force you to remember to factor out the negative later. What's my GCF of that first group? Good. I'm left with 2x minus 3. GCF here, take out the negative 2. I have 2x minus 3. Are those the same things in parentheses? Write it down.
Oh.
And I'm left with that's a pretty picture. Does well for factor.
Boy, you must have really good eyesight. I couldn't see that.
Yeah. Your eyesight you must eat carrots. Are you a bunny or something?
You know that's an old wives' tale that was made up. It was made up in during World War II. This is not a lie. It was made up in World War II, saying that carrots would help the soldiers' eyesight because they wanted them to eat more vegetables. They just wanted to eat more vegetables so they'd be healthier, not just gout with like meat all the time.
You know, I was really proud of
I know. I've really pushed my boundaries as far as truth and fables. I do have another story for you. The window. I got a response. They called me back.
What are you talking about?
You
didn't tell us about this.
I didn't tell you about that?
No. Wait, so what?
All right. Let's do some more.
Yeah, honestly, I need to know about my safety at home.
Your safety at home is fine.
No, actually, that doesn't work a problem. It would be like watching it and trying to figure out how we can get through the windows.
There's a little rule about when you're factoring stuff that has negatives involved. When I have a negative value of A, that means the parabola is opening downward. But I still have to be able to factor it. So when I go to factor this, the first thing I gotta do is what? Yes, sir.
I'm sorry, I just found a strange coincidence between this and like Watergate or something like where the missing 18 minutes, like, God forbid something happens, and you're like, well, what were these kids trying to do? Leaping out of windows. And then they go back and there's 18 minutes missing, and they're like,
There's what?
Yeah, I feel you saying.
Wait, what?
Anyway, so in this case here,
wait, what was the guy's name? Deep Throat or something? Deep Throat over here.
What?
Didn't know. when
you
he
didn't know, yeah.
Yeah.
It was the code name for the guy that wrote Watergate. Yes, ma'am.
Are we talking about imaginary numbers right now?
It's a funny code.
No.
Are we?
We're gonna do the imaginary number stuff tomorrow.
Okay,
Now,
so what are we taking
it-
notes on right now, though?
It's still factoring, still 5-2.
Okay.
Now, what happens in this case here, I have a leading term coefficient that now is -1. In order to factor this the normal way that we've been working on, what I want to do is factor out the negative. So anytime you see a negative value of A, factor out the negative. In this case, I can just factor out -1. So I'm dividing everything by -1, and I get x squared minus 10x plus 21. What times what's 21? You add together, get -10. Good. So now I just bring the -1 with it, and I get x minus 3, x minus 7, and I'm done.
Oh,
Whenever you have a negative value a, whether it's -1, -3, whatever, you always factor out the negative first, okay? And then you factor it like you would normally.
why do you have to bring the negative with it if you already flipped the sign?
Because what I'm doing here is that I've already, this problem was just factored. So if I factor this -1 out, I have to remain that in the answer. Because if I get, bless you, because if I get rid of this, then if I FOIL this, I get x squared minus 10x plus 21, which is not that.
Like, don't you kind of like, to get the, so just say the -1 wasn't there, like the second equation up there?
Yeah.
Like, wouldn't that be the same as the one above it though? Or why is it have, because don't you flip everything anyway, so it's also divided by -1?
It is, but since I took that -1 out, I gotta keep it outside of it. I'm taking, think of it as a GCF. Think of it as a GCF. Let me show you another example.
But why can't you just put
I
negative
get it,
x?
I just don't know why you like flip the signs.
And then
and
negative
keep it
x
there.
plus 7.
Like, why is it -10?
Because you were -x plus 3, -x plus 7, then you'd have positive x squared minus 10x plus 21.
So wait, so
Yeah.
we're gonna do -x plus 3 and then keep the other the same.
Okay,
It
you do
wouldn't
like,
be the same answer.
Yeah, I see what you're saying. Yeah, you would do that, but the one thing I keep trying to tell you guys is that I'm trying to show you a method that will alleviate a lot of your sign problems. If you factor out that negative first, you won't come across sign issues later. I know what you're saying. You could put this negative, it'll work out just fine, but I know how you guys are gonna screw up. I'm trying to alleviate that little quick issue that'll happen. Same thing here. If I throw,
So you can still solve it, it's just easier.
yeah. Same exact idea here. I got -3x squared minus 15x minus 12. Now, you may or may not remember this from way back when, but the very first rule of factoring was always to look for a GCF. Because if you look for a GCF, everything else becomes easier.
3.
In this case, it's 3, but I'm also going to factor out the -3, because that first term is negative. So if I factor out the -3, I have x squared plus 5x plus 4. What times what's 4? You add together to get 5. 4 to 1, yeah. And you're done. Okay. There will be times that you have to remember to bring the negative with. Always take the negative out. Sometimes there's an extra GCF tag along with it.
So if you multiply that by that, it's kind of dividing it out of it.
Yeah. It's just great common factor. You always just look for that first. It's just the easy way to go.
If you were to set that equal to 0, would you bring the -3 with both of the?
No, you don't have to. This is a great question. He's asking here, if I set this equal to 0, in this case now, the terms that I have to worry about with 0 would just be x plus 4 equals 0 and x plus 1 equals 0. Because those are in the parentheses. Now, when you distribute this in, you're not distributing it into both terms. You just really all you're doing is multiplying it into one of them before you FOIL out. So if you had -3x minus 12, wouldn't I still get -4 for my answer? Crazy, isn't it?
So you can do the -3.
You're just scaling the whole equation up.
Exactly.
You can-
Yes, that's exactly what it's doing. See how it still works out the same way. But once you're finding out the zeros, you're just dealing with what's in the terms. Yes, sir?
I got 3x plus 3 times -x minus 4.
3x plus 3, and then what was it?
-x minus 4.
Okay. In this case here, if I'm factoring this problem, You're right, your terms are correct. What's the greatest common factor here?
3.
Can I take a negative out of here? Now this is time, so this becomes -3, which means the same thing I did here.
Oh,
So you
okay, so
can't-
it's just like simplifying.
Yes. Yeah. You always want to be in simple form. All right. You want negatives out and GCFs out. Okay. Yeah.
So it doesn't matter where you put the negative, like I should just put it or the other.
Sorry. Go ahead.
Where did you get the final answer of the negative? How did you get that?
To this part here.
No, the negative 3 and x plus 4 and x plus 1.
You got right above.
Right?
Here?
Where the arrow is.
Oh, this. Oh, this came from Lee.
No, not that, not that. Okay.
Above the second
This?
one.
That, yeah.
Okay.
Where did you get that from?
All right. What times what's 4 that you add together to get 5? 4 times 1.
Oh, okay.
That's what I'm trying.
Okay.
Okay, so like, say it was -4. Could you not factor out
Correct.
-4?
Well, out in front.
So like, say it was -4x squared minus 15x minus 12.
Yeah, then you can't figure out 4. You just have to factor out the
The only
negative
time
1.
you can factor it out, factor it out is if you have like,
GCF.
so, okay, so if
But I would still factor out the -1 because I can take that out.
but if it's -4, you have to still do -1.
Yeah, just take the negative out.
So just, it would be positive. No.
Just stay with me. All right. In this case here, the greatest common factor is what? 2. But the first term is negative, so it means I'm going to factor out what? -2. Okay. I'm going to factor out the -2. I'm left with 4x squared minus 12x plus 9.
Oh, I get it.
Okay.
I understand.
See, I knew once you saw a couple more, you'd be all right. Because what happens is now I can still factor that trinomial. What's 4 times 9? What are 2 things you multiply together to get positive 36, but when you add them, you get -12? -6, -6. Remember, when I get to this point here, I'm still doing 4 times 9 to get -12. -6, -6. That's where I get the -6 and -6.
So you don't even worry about the first one after the second? You know what I mean? Because why wouldn't you do 18?
Because I took out the -2 to make it easier. You can multiply, take out the -1 and change all your signs and do 8 times -18. It's just a larger problem. And at the very end, you'll have to factor out
So you
further.
don't even worry
You
about
could do
negative for now? Well, you don't even worry about it.
First rule is always get GCFs. I got the GCF out, makes my life easier. All right. So now I have -2, 4x squared minus 6x minus 6x plus 9. Group them.
Oh. Can you just leave that up for a second?
Uh-huh. Take out the -3. Excuse me. All I'm doing here is creating another factor by grouping problem. Now I have it set up from 4 terms. I got the GCFs of both of them. I had the same thing within parentheses. I still have that -2 I keep rewriting outside. So I have 2x minus 3 and 2x minus 3.
Where'd you get that?
Yeah, that's a fully factored.
Factoring is.
Yeah.
Wait,
Yeah.
Mr. Murphy, why?
It's finding zeros, basically boils down to that. What's that?
I thought that you meant it was positive 6, that's why you.
Yeah, I do. I always do that because it was negative, negative. So that third term, if it's negative, I always do a same change opposite to force myself to remember to take the negative back out. That's all. It's just a habit thing that I was taught to do, and it's what I've always shown. Yeah.
Could you write it -2 times 2x minus 3 squared?
Absolutely. You can do that. That's fine. Perfectly fine. How many zeros does this function have?
I don't know what that means. What are you talking
One.
about?
It only has one.
What does that mean?
Is 1 0?
Yeah, what does that mean?
It means that x is only equal to 1 times.
If it said equals 0, that means it's finding the zeros. What you're doing here is you're figuring out how many, or where does it cross the x-axis. You're finding the zeros of the function. In this case here, I'm finding, if I set this equal to 0, that means I set this part equal to 0, and I set that part equal to 0.
Where do you put -2 with both of them? When you do that?
No,
The action, you just leave that out?
leave it out, because it's these. You're only worried about what's in the parentheses.
Okay.
I would only worry about this if this was like a -2x. Then I would set all terms equal to 0. Since there's no value of x, I don't worry about it. So I get 3/2 for both of them. Oops. And that's the same number. I only need to write it down once.
So what did you do with
So do you have to do that for every, sorry. do you have
Only
to-
if it says equals 0.
Only if it tells you to find the 0?
Yeah, if it says equals 0, that means you have to find 0.
Like I said.
What did you do with 2x and -3 then in the equation above?
Since it was the same thing written down twice,
Yeah.
I wrote it down here. What was left over? 2x minus 3. Just so happened to be written down. It just happened to be itself twice.
Inception.
Yes?
In real life, why would you simplify
What you're working with, when we get into the modeling part of this, it's allowing you to find the 0. And finding the 0 is where all parabolas, anything that's can be written as a quadratic, it's a solution of a problem. That's all it is. Factoring is finding zeros. Yeah.
Does it always line up that nicely?
No. Because sometimes you have to use quadratic formulas, sometimes you have to use completing the square, sometimes there's a lot of other stuff to do.
Hey, Mr. Murphy, do we ever have to use fractions to use,
Oh, for the factors and stuff?
there's like big problems like this?
I don't think so.
That would suck.
I really don't think so.
Did they talk about Watergate before it's done? Like, didn't you like call it and it's like, I think somebody left the lights on or something like that?
Yeah. Factor.
You are some good urban.
Back to that one.
Oh. 45 times 5. All right. Mr. Murphy, do you like it?
Yeah.
Wait, so that's to multiply after 225 and add it there?
What's the first rule of factor? Yeah, guys, remember.
Oh my gosh.
Seriously, why are you making your life so hard on this one?
Yes.
Factor out of 5.
Yeah. I don't know if it's better or 5. Oh, 9. They're selfish.
Find the greatest.
What times what's 9? And you add together to get 6.
Why 9?
3 and 3. What's that?
Why?
Wait, yeah, why are you doing 9 and 7 instead of 1 and 1? Yeah, don't you supposed to?
I always multiply first and last. What's 9 times 1? It's the same thing we've been doing.
Always.
9, it is.
Yeah. What times what's 9? You add together to get 6.
Well, are you always supposed to multiply that first and last?
Yeah.
3 and 3. Mr. Murphy is 3 and 3.
Except for when it's very.
Except for when it's not any 5 and less.
Give me the x squared.
Yeah.
Where there's a number. You technically really are because that's 1.
Well, yeah.
How about that?
It's 3 and 3, Mr. Murphy.
Yep.
Yes, it is.
You gotta guess quite more.
Maybe.
Yes.
Take care of your grouping.
Well, I'm just gonna step
If I can't take something out, what can I always take out?
Oh, no, I can't.
Why did you times that by one before?
If you can't factor anything out, could you always factor out a 1?
Yeah.
Yeah, because otherwise you can't finish the problem.
I don't understand the plus one in the middle.
Remember, what I'm looking at here is what's the GCF? GCF of 3x and 1 is 1.
Wow,
Why
this
do you
is.
have to do that?
Because that's how you factor. You're finding the method I'm doing here is called grouping. The greatest common factor of 9x squared and 3x is
Yeah,
3x.
I got that.
All right, the greatest common factor of 3x and 1 is 1. If they have nothing in common, you can always have 1 in common. Always.
But why have one there?
Because then what are you going to do when you're done? Because here you wind up with your 2 terms. And then this is the other part.
Alex, you're trying to make them the same, man.
I'm trying to get that trinomial written into 2 terms. And then I said bring this 5 down. Okay?
Are they the same again?
Yeah.
That's a lot of them. Alright, I like it, I think, though.
Trying to make them the same. So we got a 10 now.
Is this really fit the word?
How do you do the last step?
So.
It doesn't error in between.
How do you do the
Zero.
last step?
It doesn't go zero.
Is this our homework?
No? There are zeros here. You have to factor these. So on that first one, you have 2 and negative 4 to get negative 8. Add them together to get 7. So you had 2x squared plus 8x minus 1x minus 4. Okay? 2x, you got x plus 4. Take out the negative 1, you got x plus 4. Your zeros are easy to find. 1/2 and negative 4. You okay on that?
Yeah.
The second one, same idea. I got 15 to get to negative 8. 5 and 3 again, right?
-5, -3.
So I get 3x squared minus 3x minus 5x plus 5.
Does it matter which one comes first?
Nope.
5x squared?
The chicken or the egg?
Remember, if your third term is negative, make sure you do that same change opposite so you don't forget to take the negative out. You get zeros of 5/3 and 1.
Wait, 5/3?
Yeah.
One of them?
And then lastly, 25x squared equals 16. Is one side equal to 0?
No.
Move it. You get 25, x squared minus 16 is 0. Is this a perfect square?
Yeah.
Is 16 a perfect square?
Yeah.
Is that a subtraction symbol?
Yeah.
Most likely.
What's the square root of 25?
5.
What's the square root of 16?
4.
3, 2, 1.
I like my way better.
I still don't get it.
Your zeros are plus or minus 4/5.
I like my way better than that answer.
Oh, I heard them individually. I forgot that these two plus are.
Yeah, that's fine. You can do it like that.
Right.
What I want you to work on then tonight starts on basically the same page, 260. And we left off basically at 44. So page 260. 44 to 88.
Wow.
Every
Oh my.
other
Okay.
even.
That's fair.
That was.
93, 94, 99, and 101.
What?
Now,
Take it.
on number 99, there is a problem on page 259 that shows you how to do it. On number 99, there is a problem on page 259 that explains to you exactly how to do it. Okay? I know. Wait. Yes, sir.
Wait, is it 11 and
Yes, it's not right.
I can't hear you.
No, this is too much, because the numbers are big.
Yeah, it's only 15 problems.
Complaining about freaking out problems they were, but the numbers are big. They're big.
Now, oh well.